guys, today we're going to be doing number 6 of 2015 AP Calculus BC FRQ. Alright, let's go straight in. So number 6, the Maclaurin series for function f is given by sigma from 1 to infinity, negative 3 to the power of n minus 1 times x to the power of n over n. And it gives us the few first terms right there. And it converges to fx for absolute value of x when it's smaller than r, where r is the radius of convergence of the Maclaurin series. All right, so part A is asking us to use ratio test to find the radius. So that's pretty straightforward right there. And ratio test, we know that's limit n goes to infinity, absolute value, negative 3, and we have to substitute in n plus 1 for n, which is just going to be n, and then x to the n plus 1 over n plus 1 times just n right there, and then negative 3 n minus 1 times x to the n. All right, the reason this is flip-flop is because we're actually dividing, but it's a fraction, so we can just flip-flop it upside down. And n plus 1 and n, they both cancel out. Then x to the power of n, that cancels out, and just x is left over. And this cancels out, and just negative 3 left over. So we are left with negative 3x absolute value is smaller than 1. And negative gets canceled since it's absolute value. And we divide both sides by 3, which gives us, there we go. And this is our radius. R equals 1/3. There we go, we'll write it like that. Okay, that's part A right there. Let's go to part B. I'll scroll down a bit. All right, so part B asks us to write the first 4 non-zero terms of the Maclaurin series for the derivative of f and express f prime, the derivative, as a rational function for absolute value x within R. All right, we'll see what they mean by that later. Okay, so they give us the first few terms, which is just that plus 3x cubed. And they don't give us the fourth term, but in the problem they ask us for 4 terms. But nonetheless, we're just going to derive these, which will end up looking like this. And to find the last term, we're going to plug in 5 to the original general term, which is going to give us negative 3 to the power of 4 divided by 4, x to the power of 4. And when we derive that, it's going to look something like that should be 3 right there, so this is n minus 1. And then that's also going to switch to a minus. And that will end up looking like 3 to the power 3 is 27. And then the 4s gets canceled out, so it's just 27 cubed. There we go. And that's our first 4. Oh my god, that's terrible. Our first 4 non-zero terms. And it asks us to express f prime as a rational function. Okay, so above it states that the fx is where this whole thing converges to. And we notice that this whole 4 terms is going to keep on continuing on. But just by looking at these 4 terms, we're able to derive that this is a geometric function. And if we express it as one, it's going to become something like this, something like that. There we go. And we know the formula to find the sum of the geometric, which is a1 over 1 minus r. And by looking at this, we know that r equals negative 3x. And a1, the first term, Let's just boop, just put that over there, right there. Which is gonna be 1. We just plug these in. 1 minus 3x, and then simplify it, and boom, there we go. That's f prime of x. So here are the first 4 non-zero terms, and here is f prime. All right, let's go to do part C. It's the last part. All right, part C is asking us to write the first 4 non-zero terms of the Maclaurin series for e to the power of x, and use the Maclaurin series for e to the power of x to write the third degree Taylor polynomial for g of x equals e to the power of x times f of x at x equals 0. All right, so we know that e to the power of x expressed as a series will look like this: x to the power of n over n factorial. And if we just expand this out, that's going to end up looking like 1 plus x squared over 2 plus 6, since that's 3 factorial, x cubed. That's just kind of just keep on going on. All right, and then the problem is asking us to write the third degree Taylor polynomial of e to the power of x, which is that, times f of x, and they give us the first terms of f of x. All right, so to find the product of e to the power of x and f of x, we're just going to multiply these two. So it asks us for the third degree polynomial, so I'm not going to write the terms that is going to be higher than third degree, since it's not going to be included in the final answer anyway. So, for example, multiplying this term and this term is going to give us a 6th degree term, and we don't need that. So I'm just going to exclude that. All right, so let's get to multiplying. So x times 1, that's x, plus x squared, plus x to the power of 3 over 2, and then times this is going to be higher than third degree, and we don't need that. So there we go. And then 3, 2, just keep on multiplying. There we go, there we go. And there we go. That's all the terms we need. All right, so we just got to add all these terms up. There's only 1 degree. So x plus the second degree is right here and here, which is going to end up being a negative. Negative 1/2 squared plus, all right, so we got 3 minus 3/2 plus 1/2, which is going to be 2x cubed. All right, here we go. That's the answer. So we just multiplied the e to the power of x and the first terms that they gave us to find the third degree Taylor polynomial of g to the power of x, or g of x, which is the product of those two. There we go. That was number 6. Thank you, guys.